Well, good morning, everyone. Welcome to another episode of Cosmic Coffee from Lowell Observatory. I'm Jeff Hall, and I'm here this morning once again with Lowell Observatory historian Kevin Schindler, who is calling in from a fairly historic location this morning. Hi, Kevin.
Hey, great to see you, Jeff.
Great to see you.
Far away, but it seems
about 100 yards up the hill from me right here in the Clark Telescope Dome. And we're going to be talking a bit about that this morning on some Cosmic Coffees. We're going to focus on figures and work throughout Lowell history. And if you're a regular viewer, you'll remember Kevin was here last month and we discussed the rather enigmatic life of Robert Burnham Jr. and his amazing celestial handbook. And that was an excellent conversation. Today, we're going to go a little farther back into Lowell history to another figure that is perhaps not as well known as he ought to be, and yet has a very long association with Lowell, as well as one of the fundamental discoveries in astronomy of the 20th century. And that is Vesto Melvin Slifer. And Kevin is here today to tell you all about one of our most interesting and significant researchers. Kevin.
Thanks, Jeff. Let me start my slideshow here. Yep. And does that look all right?
I've got it fine, yep.
Okay, I love when that happens. So, if you're in the astronomy world, you've heard of VM Slifer's name. If you've visited Lowell Observatory, you've probably seen it or heard it. But otherwise, his name just isn't as well known as somebody like Hubble, who has a space telescope named after him and others. And yet, when we look at a lot of his scientific accomplishments, he really had a remarkable career. And so, we'll talk about that a little bit today of his career and why he isn't as well known. And I don't think it's, us here at Lowell trying to be homers and give this guy more credit. I think that's the consensus among people in astronomy in general, that this guy is one of the understated heroes of astronomy in a lot of ways. And so there's some reasons for this. And so we'll talk about that today. I thought we'd start out and just talk a little bit about VM Slifer's youth, because, looking at his background helps show us why, some of the reasons why he maybe isn't as well known as some others.
Yeah, Kevin, I think you might want to maximize your window there. At least on my screen, I can see it fine. It's showing up a little small. There you go.
How's that? Okay.
It's better.
Great. Thanks, Jeff. So 1875, he was born in November in Indiana. The middle of Indiana, the middle of the Midwest, Midwest family all the way, farming family, down to earth, souls of the earth sort of folks. And he came from a large family. He was one of 9 children. And I think this picture kind of shows to me the robustness of this Slifer family. Mom and dad are down below here in the middle. And this is all 9 children who lived to adulthood. And you can see VM's getting some gray hair here. So it's remarkable when you go back to this time when a family that large, you wouldn't lose a few. So here's VM, kind of toward the middle. And then on the left side is another Slifer we're familiar with here, EC, his younger brother. While most of the Slifers went into farming, VM and EC went into science. Another one became a professor also of a different topic. But VM and EC from this farming family really made a name for the Slifer family in science. So this is the family, small town, America. And I thought I'd kind of tell the story of Slifer and how he gets to the observatory by kind of telling a parallel story from 1894 till 1901 of comparing what VM was doing versus what was happening at the observatory, because their worlds eventually coalesce. So in 1894, VM graduates from high school in Frankfort, Illinois. So he was born in Mulberry, went to school in nearby Frankfort. Frankfurt is also the home of Grandpa Walton on the Waltons, for those who remember that show. So Will Gear grew up there also years after VM. So VM graduates from high school. In the same year, over in Arizona, Percival Lowell founds Lowell Observatory, initially to look at Mars and try to prove the existence of intelligent life there. And he borrows two telescopes, an 18-inch telescope from a telescope maker named John Brashear, and then a 12-inch from Harvard College Observatory. So 1894 is a tipping point for both VM and the observatory.
Right. And at that point, so Lowell would have been 39 at that point.
Right. Yep, 39 years old. So the next year, VM is graduated. So he hasn't really decided on a career yet. So he decides to teach local high school for a year, just to figure out his future. Meanwhile, at the observatory, they set up shop for that first year, several months, to look at an opposition to Mars. The weather was really bad, and Lowell decided two things. One is, let's return the 12 and 18-inch telescopes. We might look for another place to set up another telescope, but Flagstaff right now doesn't look so good. So let's return those telescopes, and we'll also order a new 24-inch refractor that'll be the mainstay of the observatory. So the biggest telescope was that 18-inch Brashear, and so Percival Lowell told his assistant, Andrew Douglas, to return it to John Brashear. So before returning it, he wanted to clean the lens, and they were using alcohol. And as the recollection from Douglas goes, they ran out of alcohol, so sent a young boy to downtown to get some more. And when they applied it on the surface, some of it remained and etched a little hole in the lens. And this was, for a telescope lens, this was tragic. I mean, it doesn't take much to really throw it off. And so Percival Lowell wrote to John Brashear and really apologetic, what can we do to make up for this? Let me send you a check. He sent a check, and John Brashear was such a kind person. He said, no, don't worry about it. We'll figure something out. I don't know what, but we'll figure it out. So keep that in mind. Percival Lowell feels like he owes John Brashear something for the damage to the lens. So while that's happening, the following year, VM decides after teaching for a year, maybe he's going to go to college. I'm not sure what he wants to study, but he'll go to college. And then the observatory, here's a young astronomer named Wilbur Cogshall. And he and some other new hires are going to go down to Mexico, because the new Clark telescope, the one that's right behind me, and the one that also is shown in this picture, is ready. They're going to take it to Mexico, where the weather is better, and Mars will be higher in the sky for this approach of Mars. So they go down there, spend several months observing.
And I've always been amazed by that, given the conditions out here in 1896. And, let's just truck this giant telescope several hundred miles off to Mexico.
And, we say it so cavalierly, if that's a word like that. But, for you, Jeff, and others of us who were here for the telescope renovation several years ago, it's a project in modern times with cranes and modern equipment. Right. They didn't do any of that stuff back then.
Yep.
So when I say, they decided to take it down to Mexico, it was an operation to do that.
They didn't exactly just head down I-17.
No. So the following year, VM enters Indiana University. Indiana, it's one of the state universities, so it seems like a natural place to go. He hasn't decided on a major. He just decides he wants to go to college. Meanwhile, on the observatory front, they're done in Mexico. They decide to return the telescope here to Flagstaff. But Percival Lowell also has a nervous breakdown while this is happening. So he is out of action for a couple of years. He goes back east, travels around the world to just rest up and recover. Meanwhile, he puts Andrew Douglas in charge of the observatory. So it's Douglas there, pretty much everybody else is left. There's still a couple staff, but Wilbur Cogshall is no longer on staff. He left. So this is how it goes for a couple of years. We get to 1900, and this is a big year for Indiana University. They've hired Wilbur Cogshall, which will have a lot of influence on the story. Also, their Kirkwood Observatory was built, which was critical to them really developing their astronomy program. And the hiring of Cogshall and the observatory, the new observatory, really got VM Slifer's attention, and he decided, shoot, I'm going to study astronomy. That's what I'm going to major in. Meanwhile, at the observatory, Percival Lowell finally figures out how he can pay back John Brashear. John Brashear doesn't want to just take cash, and so Percival Lowell decides, I know what I'll do. I'm going to buy a spectrograph, an instrument. This is a picture of it attached to the Clark behind me. This is an instrument that allows you to determine, the compositions of things in space, and also, as we'll see, relative motion of things. So Lowell had been interested in the rotation of Venus, and there's an argument at the time whether it was really, really fast. Some people thought its day was similar to Earth's, maybe 23, 24 hours. Others thought it was more like 200 plus days. And there's a discrepancy because Venus is just this, covered with clouds. There's no point on it to really see easily to watch it go around one time to measure its rotation. So Percival Lowell decided, I'll get a spectrograph to study this, and we're going to get it from John Brashear, and we're going to order the best possible one he can make. By doing this, Lowell's conscience will be clear. He can pay back John Brashear. So, already we can see, if that telescope hadn't happened with the telescope, would Lowell have gotten this quality of a spectrograph?
Yeah, but and like the telescope, this very spectrograph is still on display here 121 years later.
Right. It's a couple hundred yards from where I am in our Putnam Collection Center. And in fact, I thought about operating from there today, but with some staff coming and going, I didn't want to get anybody's way. But it's great. All the stuff we're talking about, or most of it, like you said, is still on display here. So 1901 is when this all comes together. VM Slifer graduates from Indiana University in his mechanics and astronomy. And then also, Andrew Douglas, who had been in charge of the observatory for several years, he's getting pretty skeptical about Percival Lowell's studies about Mars and his interpretations of these supposed canals, these linear features that Percival Lowell and others think are there, and we know today they aren't. But Percival Lowell, even though he was out of action, he was still sort of active, working on a book and doing some papers. And Andrew Douglas was a real humble guy, and he was devoted. And he wrote a letter to Percival's brother-in-law, William Lowell Putnam, who is our current trustee's great-grandfather. Great-grandfather. And Douglas wrote, I don't want to be bad-mouthing Percival, but his work is not respected in the scientific world, and these are the reasons why. And he was really trying to be nice about it, but before he knew it, he was fired. And as near as we can tell, Putnam shared the letter with Percival Lowell, who, Percival Lowell had a larger-than-life personality, flamboyant, intelligent, at the front of any conversation and any argument. He didn't want to put up with somebody debating like that, so he got rid of Douglas. Mm-hmm. And this hurt Douglas a lot. Because he really was devoted to Lowell. But it's interesting because just as this is happening, they're getting the spectrograph. It's going to be coming soon. So later that year, as the spectrograph is just arriving, Percival Lowell gets a letter from Wilbur Coxall in Indiana, which says, "Hey, I've got this young guy who just graduated. He's looking for some work somewhere. Can you put him to work? Doing something, even temporary?" And Percival Lowell was still pretty wounded by Douglas, and said he didn't even want to take anybody on right now. And he sent this response to Coxall and said, "I shall be happy to have him come when he is ready. I have decided, however, that I shall not want another permanent assistant, and take him only because I promised to do so and for the term suggested," which was months to a year. If owing to this decision, he prefers not to come, let him please himself. Well, V.M. Slifer just got out of college. He's got a job for a few months or so he decides to go down there. And as we now know, he spent the rest of his career here and made quite a name for himself. So
now, coming from the family he did, do you know, were the parents supportive of VM going off in this rather different direction?
There's very little known about Slifer's youth, and those sort of questions we've never found answers to. Hopefully we'll track some down, but there's a lot of Slifer family members. There are a lot of, with 9 family members, there's a lot of family we've been in conversation with, but nobody really has a sense for that support that they had. So, we kind of went into detail here about how Slifer got here, but I think it's just, it's just like the discovery of Pluto to me. There's so many unlikelihoods that he even got here in the first place. But he did get here. And so he starts getting to know the spectrograph. And again, here's that picture with the telescope that's behind me with the spectrograph attached to the left end. And you can't see all the spectrograph because it's got this box that it was stored in. And they would put that on the end when they weren't using it. But Slifer, it took him years to get to use this well because he had to try different prisms and different times of exposure and all sorts of things. It was a very painstaking operation. And I'll point out that up to this point, astronomers had used spectrographs and they studied stars, and they would do exposures of a few hours. That was about tops. And so keep that in mind because we'll find out what Slifer did and why it was so revolutionary. So the first thing he did was to look at Venus. And you might look at this and say, oh, is that one of Lowell's drawings of Mars? Actually, this is one of Lowell's drawings of Venus with the supposed spokes that he saw. And if the canals of Mars seemed outlandish, then markings on Venus, which was shrouded in clouds, was even more unlikely. So anyways, Douglas studied this, and he confirmed spectroscopically that Venus did have a very slow rotation. This was really important to finally proving that Venus moves slowly. So this was a good initial study with this. Of course, Percival Lowell, another reason he had anybody helping him was to support his Mars research. And, this idea that there were canals crisscrossing the planet and this intelligent life bringing water from the polar ice caps. Lowell wanted Douglas to use the spectrograph to study Mars and see if he could detect any water vapor there and other elements. And water vapor would help bolster this idea that there is actually water there. And Slifer did this. And in fact, years later, he would climb up to 11,500 feet on the San Francisco Peak, Schultz Peak, or sometimes mistakenly identified as Doyle Peak. If you look at the San Francisco peaks from downtown, it's the rounded peak to the lower right. So he had a field station up there for years that Slifer would go up and get above some of the Earth's atmosphere and see if he could detect water vapor on Mars, but the results were negative. So that didn't prove what Lowell was hoping for.
Right. It's interesting how, over decades to centuries, science proceeds along parallel threads because, of course, today we are using considerably more refined spectroscopy to do exactly the same thing. We're looking for water vapor, except now it's in the atmospheres of planets around other stars.
And so, this work that's being done like what Slifer did really lays the groundwork for further studies like what we're doing today. And I throw this slide in here just for fun because field station, they used it for years and it was used by other observatories off and on. And at one point was the highest observatory station in the world. Today it looks more like this, but it's hard to tell, but you can actually still go inside the remains of this building and campers will use this. And if you look, you can just make out this post. That was a ponderosa pine tree they hacked off at a 35-degree angle and mounted a telescope on it way back when. And that still remains as the corner of that building there.
Yep,
So,
definitely a fixer
never
upper.
been up there. But we need to hike up there one of these days. It's pretty cool to see. So, Lowell has a lot of ideas of what he wants Slifer to do, but he also sets the stage that for something that our current trustee Lowell Putnam points out, and that's the openness to do your own research at Lowell Observatory. Lowell had a lot of ideas for Slifer, but he said, in your spare time, do some other stuff. And he wrote this note to VM, by all means, make your star measurements for velocity whenever there's no pressing planetary work, and good luck to you in the results. Well, Slifer had a lot of pretty darn good results. One of the first things he did when he started studying stars was to look at Beta Scorpii, which is the one on the right, and he took a spectra of it, and the spectra was mostly kind of fuzzy lines, but then there was a very distinct pattern of calcium lines. And what he realized was something that had been theorized before, that there was some sort of gas out there that we know today as interstellar gas. So Slifer proved the existence of interstellar gas with some of his early spectroscopic studies. And sort of related to that, he was also studying a nebula in the Pleiades. And in looking at the spectra didn't match what you would expect for the Pleiades. Instead, it matched the spectra of a nearby star, Merope. And he realized that the light he was looking at was reflected off of something out there that he called pulverulent matter, which today we know as interstellar dust. So if Slifer had done nothing else, he proved the existence of interstellar gas and discovered interstellar dust. I mean, that's pretty remarkable in itself, I think. But then it gets really interesting because Slifer is now getting to be an expert with the spectrograph. He's looking at a lot of different stars and gas clouds and such. In 1909, Percival Lowell kind of summarizes his idea of the evolution of planets in this book called The Evolution of the Worlds. And he used the term planetology. And, if we think about the time, we're, 50, 60 years after Charles Darwin came out with this theory of evolution. And after Darwin came out with this, evolution was used to explain a lot of different things. It was adapted to economics and other things. Herbert Spencer, who was British, had come up with this idea of planetary evolution, where planets are formed, they're young, they're gaseous. As they get older, they get rid of some of that gas and they become solid, and they're middle-aged. So the young planets are Jupiter and Saturn and Uranus and Neptune. They become middle-aged, where they still have some of the gas around them. So Venus and Earth and Mars. And then you have, later on, they lose all of that atmosphere. They just turn into a dead, dried out place like Mercury. So this is important because it really shows another reason why Percival Lowell was looking for life on Mars, because Mars was in the middle stage of evolution as he saw it, because Lowell really bought into Spencerian evolution. Mars was in the right stage for evolution, and so there must be life out there. And these canals sort of proved it in his mind. So it's kind of interesting how that ties together. But something else that came out of this relevant to the story today is that in looking at the evolution of planets, Lowell saw these fuzzy objects out in space called spiral nebulae. And he and other astronomers believed that they might be protoplanetary systems, young planets being formed. And so as he's writing this book about the evolution of worlds, he wants Slifer to look at these spiral nebulae to see if they are in fact young planetary systems. Look at the spectra to see if they match what Jupiter and Saturn spectra show. And so Slifer is skeptical about this because these things are really faint. And so it's going to take a lot longer than just a couple hours to get a spectrum. He's going to have to do it over 8 or 10 or even more hours. And he's skeptical about it, but he said, okay, I'll try it. And so he first looks at the Andromeda Galaxy, and he takes some exposure. He starts this in December of 1912, just after Arizona was celebrating statehood. And he takes these spectra and finds something startling, that he detects that the Andromeda Galaxy is moving towards us at a rate of some 300 kilometers per second, which is several times faster than anything has ever been detected moving in space. So this just didn't make sense. He writes to Lowell and said, hey, this is a weird, result. And Lowell says, study more, look at more spiral nebulae, because we have to remember this is 1912, 1913. This is before we had a good understanding of galaxies.
Yep. Even our own galaxy. I mean, even our own galaxy, really, our understanding of the structure of the universe pretty much ended at Neptune.
Right. And there was a question, and this would become a big issue in the ensuing years, were all these fuzzy things part of our own system, or their own island universes out there? Were they something separate? And so this is really pretty interesting stuff. So VM continues to study, but he's going to look at other objects that are a lot fainter. Because Andromeda, as these go, is about the brightest one. So he starts really developing the techniques with the spectrograph, and he starts taking spectra that are 10, 20, 30 hours, some up to 60 hours, which is just mind-boggling because you can see them here. The spectrograph is on the here's the butt end of the telescope. Here's the spectrograph. And he's looking through a little guide eyepiece here to track the telescope. So during the duration of this process, he has to guide the thing and look through that eyepiece. He's doing this for up to 60 hours. And so he would come out all night when the object in the sky, he points the telescope and spectrograph at it, follows it as it moves across the sky over hours. And when it gets too low, he closes down the lens cap and aperture and everything, and waits till the next night when that object is back up in the sky. He repoints the telescope at it and lets it track again, and he follows it the whole time again.
Yep. And any of us who live in Flagstaff know these are not balmy nights. This is out there in the cold.
Yeah, he was doing this in January, February of 1913. Yeah. And nobody had ever come close to doing any exposures this long. And what he found was stunning. This is a picture taken a century after he started studying it. This is the Sombrero Galaxy. Boy, if Slifer had this telescope to use, this is from our Lowell Discovery Telescope. But this is what Slifer studied. And he found that this was moving 1,000 kilometers a second away from us. What do you make of this? And he studied more and more and realized that these spiral nebulae, as they were called, were moving at incredible distances, mostly away from us. And in 1914, he presented his results at an American Astronomical Society meeting in Illinois, and he got a standing ovation. Mm-hmm. You've been an astronomer for more than a couple of years now, and you've been to a lot of science meetings. How many standing ovations have you seen at science meetings?
They're uncommon.
Yeah, they just don't happen very often. But the scientists realized, and they didn't quite know what to make of it. But one thing it said is that these things indicate that the universe must be much vaster and much older than we ever thought. And this changes our understanding of the universe in so many ways. And so, not sure what to make of it, but it's really going to change astronomy, and it did. And this is an interesting picture. The red arrow shows VM Slifer, And over on the other side, standing, not surprisingly, in the front row, is Edwin Hubble, who was a student at the time at University of Chicago. They're not only on opposite sides of the crowd, they were opposite in so many ways.
Yeah.
Slifer, the small town, low key, soft-spoken person. Hubble, who in many ways, like Percival Lowell, outspoken, ego among, beyond egos. There's a great book by Gail Christensen talking about some of the things that Hubble would do just to demonstrate how much superior he was to everybody else. So really fascinating dichotomy of personalities there. Slifer listened carefully, and this really informed his later research. In fact, Slifer would continue over the next decade to take more spectra, but one problem he had is the Clark telescope wasn't enough telescope. He needed more aperture. Yeah. 24 inches, he needed something bigger. And the observatory did by then have a 40-inch telescope, but it was being used for other stuff. And also, Slifer, after Percival Lowell died in 1916, Slifer took on a lot of the administrative duties. And there wasn't as much money coming into the observatory, so Slifer became involved, making money in other ways, investing in real estate and other things. So he continued doing research, but not as much in the spiral nebulae. And the spiral nebulae we know today are galaxies. The Andromeda Nebula, as it was called, is the Andromeda Galaxy, and so on.
And I love Slifer's paper on this in the Astrophysical Journal, because there are a number of papers like this in the literature that are, instead of some magnum opus, they're 2 pages long, and just here's the observations, here's the data. And you've talked about Slifer being unassuming and soft-spoken, and there's this comment at the end of his paper, and I can't recall it verbatim, but it's something to the effect of, we really ought to look at more of these because there might be something in all of this. And it's one of the great understatements in the entire astronomical literature.
And that's another difference between Slifer and, Percival Lowell and Edwin Hubble, that Hubble and Lowell were theorists. Slifer just the facts, ma'am. And he did have ideas of what it meant, but his publications, as we'll see a little bit later, were not long exposés about trying to understand what it meant or make interpretations. It just wasn't. And, the history of science shows us quite often people remembered are those who make discoveries, but also those who make sense of the discoveries. And that's certainly what Hubble did. Hubble's work was used by others. Particularly, we remember Hubble because Hubble used this information, his own observations, to come up with important things like the Hubble constant, and really elucidated the theory of the expanding universe. Slifer made the first detection of the expanding universe in 1913, but it wasn't until the late 1920s that Hubble was able to use the distance and velocity, put all this stuff together, and make sense of what it meant. And that's why he's remembered, because he really summarized it well.
Hey, Kevin. So now there's a question in the chat that you might enjoy answering from DP. It says, Lowell has a legacy of taking chances on unknown new employees that have ended up being hard workers who make a great difference to Lowell. Do we still carry on that legacy in more recent times?
I would say unqualifyingly, yes. I mean, Lowell brings in world-class scientists and world-class staff doing other things around here. But sometimes, our staff are folks that don't have a background in this or haven't, made their bones yet, as it were, in the field, but have come on and just, turned into magnificent staff members. I think of people like, Samantha Gorney, who grew up in Flagstaff, came up here as a little kid, went off to school, went to college at U of A, came back, and now she's running our entire education program, or Todd Gonzalez, who came on. I remember interviewing him, and it was between he and somebody else, and it was almost a coin flip. And looking back now, Todd has been, a godsend to the observatory. Those are just a couple examples of I think there's, as we talked about before, Jeff, there's a personality of Lowell Observatory, and it's not only getting people qualified skill-wise, but also people qualified that, have this it factor, and that love the observatory and have, the Lowell way. I don't know if we've clearly defined what it means to be part of the Lowell family or the Lowell way, but people like Todd and Samantha are certainly part of that.
Yeah, and on the scientific side, certainly one thing we've mentioned a number of times in other contexts is the unique ability of researchers at Lowell to carry on these projects that require a huge amount of observing time, whether that's, a concentrated campaign or just over years to decades. And I think the work that Slifer did, the whole search for Pluto, right? You don't find something like that immediately. You just have to stay with it. And the fact that we own all of our own instrumentation, rather than having to rely on piecemeal access to national or international facilities, which we also, our faculty certainly takes advantage of, but it gives us a real competitive advantage in the world of what we call time domain astronomy and carrying out these projects there. You just need gobs of observing time to unlock these hidden patterns out there, or find something like a faint little planet lurking out there amongst hundreds of thousands of stars.
And I would say that, that started with Lowell and VM Slifer. Slifer went, Douglas did some of his own research, but Slifer really, did this. And, to Lowell's credit, he didn't get in the way of this. I mean, Lowell, for all his, larger than life and ego, he also let Slifer take credit as it came and didn't try to take it from him. And I think that was an important thing. And as you said, through the years, we see these long-term studies, one that you've been involved with looking at the sun and sun-like stars over time.
Right. And, and the other point, and we try to make this, particularly to when we can be open, and hopefully that's soon again, to kids who come through, Lowell is often criticized for pursuing what, might be regarded as, the harebrained idea of canals on Mars and all this, but there is nothing wrong with pursuing a weird or controversial notion. Sometimes those notions turn out to be wrong. But often they turn out to be right, or thinking, incredibly outside the box. I mean, imagine right at about the time Lowell was observing Mars, over in Europe, you had Einstein starting to come up with the ideas that, maybe a second isn't always exactly a second. Maybe the way the universe is put together and the nature of space and time is incredibly weird. And that kind of very out of the box, even creative thinking, sometimes it leads down an incorrect or dead end. Sometimes it results in a fundamental shift to our understanding of everything. And that's the nature of science. And you have not failed if you've pursued something and it's turned out to be wrong.
And, there's a young guy named Clyde Tombaugh who was hired here to look for a planet. And an astronomer once told him, "Young man, you're wasting your time. We found all the planets." And lo and behold, we can't close our minds too much. That was perceived as a harebrained search by a lot of people, and yet look what the result was.
Right.
And I'm going to just finish off here and summarize the rest of VM's career. But beforehand, we were touching on that idea of being here at Lowell and what it means to be part of the Lowell family, as we call it. And I think a quote that goes back to John Hall, no relation to Jeff, but a former director here, and then Bob Millis, a longtime director here, that said, "You don't work for Lowell, you are Lowell." And I think that gets to the crux of, what it means to be part of the Lowell family. So let me just finish off here. Slifer's peak activity really was when Percival Lowell was alive. Afterwards, not as much finances, like I said. Slifer was involved in administrative duties. He did what he could with the Clark, pretty much. Couldn't do anything else. He did get involved with looking at spectra of other things like eclipses and comets.
I do sympathize with that, with this slide.
Yeah. That doesn't happen in modern times, right?
No, never happens.
At least, part one of that. I show this slide because this is from a 1923 eclipse. And if you look in the middle, that's the spectrograph attached to this Rube Goldberg contraption, solar viewing contraption for an eclipse. So he did do some of the things like that. He led the charge and developed the program, and then hired Clyde Tombaugh, who discovered Pluto. But Slifer's one working with the trustee, Roger Putnam to recommence Percival's search. So that was a big thing. And after the discovery, that took everybody's time handling that. VM was also a member of the community, just like his brother was. Helped found the society that led to the museum in Northern Arizona. He was one of the founding members of what was then called the Community Hotel that we know today as the Monte Vista. There's a lot of great stories of things that he was involved with. If we look at his career in sum, we can see from this, he was awarded a lot of several honorary degrees, several prizes. So in the astronomical community, he was highly regarded. But as something you mentioned before, Jeff, I think one of the things he isn't well remembered for outside of that community, again, when he published, he didn't come up with big theories. He just said, this is what I've observed. I went back and calculated he wrote 103 papers, and they averaged 3.5 pages per paper.
Right.
And there's not a lot of room there to say much. Just give the data.
Just facts.
And so I think this fact that his personality wasn't Percival Lowell's. In fact, he was overshadowed by Lowell and Hubble because he just wasn't that way. He was a modest guy. He didn't publish. I don't know. You could argue he should have published more or theorized more, but that's not the kind of scientist he was. And then, really the 1920s and on, he spent a lot of time working on other stuff. And by the 1940s, the observatory was in a bad way. It was considered by kind of a backwaters by a lot of astronomers because there wasn't much going on. There wasn't much money to do research. VM was the director, but through these years, there wasn't much going on. It wasn't until the 50s that we started getting funding from outside sources to establish the current model of writing grants and that sort of thing. Mm-hmm. We really came out of that. So, it's just a really interesting person in the history of astronomy, history of Lowell Observatory, and complicated in a lot of ways because he made so many great contributions. You could argue that he was partly responsible for the observatory slowing down for a while, the 40s and 50s, but his scientific legacy is remarkable. Look at the detection of interstellar gas, interstellar dust. I don't think I mentioned that he also demonstrated the rotation of what were then the spiral nebulae and how they were rotating. And then, the expanding universe stuff. It's really pretty remarkable what he did.
Yeah, certainly. And as we wrap up here, we'll just ask the tech crew to ask for any final questions from the viewers. But Slifer was also a little bit. I don't think victim is quite the right word, but in terms of where he was in the observatory's history, we ended up in this 10-year legal wrangle with Percival's widow after he died, and that's a draining thing on the institution. And Slifer was caught up in all of that. But then, as soon as we came out of that in 1927, then it was all that restarted the Pluto search, and that in its own right, the expanding universe observations are perhaps some of the most fundamental observations of the 20th century. But discovering Pluto, remember we said earlier, before we understood galaxies, Neptune was kind of the end of our understanding of what the universe's structure was like. And in discovering Pluto, turns out, that's the first of a whole new class of planets and small bodies out there in the Kuiper Belt. And the next one wasn't discovered for another 62 years. So in a way, that opened a whole new frontier of study that we still pursue very actively here today amongst our faculty.
And something interesting, I mean, for all my years in public program, I have a perspective from that angle, I guess, is, you can argue what the word important means and what's the most important discovery in Lowell history. I don't know, it's hard to define that, it depends on how you look at it, but there are several, like you said, fundamental discoveries. The expanding universe, that changed our whole understanding of the universe. Pluto changed our understanding of the solar system, but also so much helped us popularize astronomy to where it's not just, in the, as you would say, Jeff, in the ivory covered walls. It's out and there for everybody. The discovery of Pluto, which VM played a fundamental role in, really helped expand our reach around the world. It made Lowell Observatory a name around the world. And that helped turn this into what we are today, this global place for scientific research and sharing that research with people.
Right, with our very own 4-meter telescope and a world-class new visitor center in the making. So yeah, and now from Slifer's day, what do we have now? About 125 employees and a $14 million operating budget. I always wonder, if Percy could or perhaps does look down at the observatory from somewhere. I think he'd be pretty pleased with what he launched 126 years ago.
Just as a closing thought, Lowell thought there was life on Mars. There's not. He thought there was a ninth planet out there, and the planet he thought was there actually doesn't exist. Clyde Tombaugh happened to find Pluto near where Lowell thought this really big planet was. Lowell was trying to make a name for himself. That's why he did all this stuff. He was trying to carry on the Lowell name. He went to his grave unfulfilled because he didn't, in his mind, do it. We look a century later, and he probably did more. He didn't realize it, but his name is bigger than he probably could have envisioned it because of what's happening based on what he put into play. So, these stories all tie together, our past, our present, and our future, and it's great to connect it all.
Yep, and as we go forward, we will continue to try to support and inspire all the Slifers of the future, and who knows what discoveries they're going to make throughout their careers. So with that, I'm going to say thanks a lot, Kevin. Very, very interesting discussion of one of Lowell's most significant figures. We will certainly be pursuing other topics like this as we go through the year on Cosmic Coffee. So watch our website for announcements about those, and we'll look forward to seeing you next week. We're going to go back to observational astronomy. I'll be here with some of our educators, and we're going to discuss the phenomenon of the Messier Marathon, because our educators are going to be carrying one out in a couple of weeks for your online enjoyment. This is the time of year when you can kind of do that and catch all the Messier objects in one night. So we'll talk a little bit about another figure from astronomical history, Charles Messier, and his immortal catalog of astronomical nuisances and the beautiful objects we can find therein. Until then, watch our website for other ongoing things like our interactive stargazing. We are hopeful we will be able to ramp up our on-site visitation in the not too distant future, so we'll certainly be advising you about that. Until then, stay well and healthy as always, and we'll see you next time.